Okay. So 3 times the sine of B equals 8 times the sine of 42. Divide both sides by 3. And then we have the sine of angle B equals 8 sine 42, all divided by 3. So what do you think I have to do now to cancel out the sine? What's the opposite of sine? Inverse sine. So we're going to do the inverse sine. I'm going to put the inverse on both sides. That's going to cancel out. So I'll have angle B equals the inverse sine. And then you're going to have to type this in with the fraction. So you need to type it in exactly like that. Because I'm trying to find an angle, I need to use the inverse. So if you're trying to find something inside, we have to do an inverse.
Why is the inverse sign not clear to one where it says 8 sine 42?
Huh?
Why is the inverse not clear the other one?
It did.
The 8 sine 42?
It wasn't a sign over there to clear it. You got to have two opposites to clear. Opposites cancel. So over here, I had a sine and an inverse sign. They cancel. Over here, this sign is over the whole fraction. Not just this, it's the whole thing. So it doesn't clear that off. No. All right, so type that in your calculator. What's your calculator saying? What? Domain error, which tells us that we don't have a triangle. So we get an error. So if you get an error, that means that there is no triangle. No triangle. So let's talk about that. Why is there no triangle? The reason why there isn't a triangle is because based on the information that they gave us, angle of 42, a side of 8, and a side of 3, it's impossible for this side, which is little c, to be long enough. So what that means is that this side is not long enough to close in the triangle. And if it's too short, then there isn't a triangle. So this example, this is why there is no triangle. That's why it's ambiguous. Again, we don't know if we have no triangle, one triangle, or two triangles. If you get an error, lucky you, it's no triangle, move on. Any questions? Let's move on to example 6. Let's fill in what we know. So we have ABC. So I know that angle A is 34. I know little a is 2. I know little b is, oh, I put that in the wrong place, sorry. Little a is 2 and little b is 3. So again, we're going to start off by finding angle B. Let's see if we get an error this time. So we're going to take the sine of 34 over 2. Set that equal to the sine of angle B over 3. Cross multiply. So we're going this direction and this direction. So that would be 2 times the sine of B equals 3 times the sine of 34. Divide both sides by 2, because again, we're trying to solve for B. And what we're going to have to do, which I'm not going to write out this time, is take out the inverse. Take the inverse of both sides. So we have the inverse sine of 3 sine 34 over 2. And we're going to round everything to the thousandths place. So this time you shouldn't get an error, right? Did you actually get a number?
Yeah.
So I'm going to call that B1. So B1 is 57.012. Now let's find C1. So in this triangle, I know that this angle has to be 57.012. We know that triangle sum, all three angles add up to 180. So to find big C1, you're going to take 180 minus 34 minus 57.012. That's how you find big C. So this angle here has to equal 180 minus big A minus B1. If you type that in your calculator, you should get 88.988. And then the last thing we need to find is little c. That's what we don't know. So let's find little c. So we need to do the law of sines again. So that would be the sine of 34 over 2 equals the sine of c, angle c, all over little c. Now this time I'm trying to find a side, so I won't need to do an inverse, okay? If you're trying to find whatever side I'm trying to find, I have to put the angle on top. Yes, Tamaya. How did I find B and C? Oh, triangle sum. So all the angles inside of a triangle have to add to 180. So that means that this angle is going to be 180 minus 34 minus 57.012. So now find little c. So in order to find little c, that means we have C1. So C1 equals, and it's going to end up being, after you do your cross multiplication, because it's a proportion. So after you cross multiply and divide, this is what you should have. Again, it's just a simple proportion. And for C1, you should get 3.576. So we know we definitely had one triangle, and that's all the information. So now let's talk about, well, what if it is two triangles? So if it is two triangles, I should have probably oriented this triangle a little differently. But if it is two triangles, the second triangle, I'm going to redraw this. So I'm going to just kind of draw this visual. So let's say this is B, this is A, this is C. So we have A, B, C. So there's if you look at this one, notice how we have, there could be either this triangle here, or it could be this triangle. But going back to what we know about geometry, what do we call these two angles? Does anybody remember? What do we call these two angles? It's begins with a L. It's two words. Linear, pair. And they equal 180. Okay, so this is what I want you to know is if there is a second triangle, that B1 and B2 will equal 180. That's if, okay? So let's see if we have a second triangle. So let's find what B2 would be. So B2, so we already solved the first triangle. Now we're trying to figure out, do we have a second triangle? So we're going to find B2 by taking 180 minus B1. And when we solve B1, we got 57.012. Which, go ahead, type that in your calculator. What do you get for B2? So for B2, you should have 122.988. Any questions about how I got that B2? So if that's my new B2, we already know angle A. Angle A has not changed. That's still 34. Let's see, do we have enough to have a second triangle? In order for there to be a second triangle, these two angles have to be less than 180. And when you add those two together, B2 and A, do you get a number less than 180? So pick up your calculator, add 122.988 and 34. Do you get something less than 180? All right, so that means we do have a second triangle. So C2 is going to be 180 minus B2. I got this new pen and it's kind of weird. So when you subtract those two angles, you should get that big C2 is 23.012. And then the last thing we need to find is little c2. So little c2 is going to be sine of big A over little a equals the sine of c2 over little c2. Go ahead and cross multiply and solve that. This is big. I know that this looks like that's big. And then now I'm doing little c. Yes.
Is the A also, is this one an A2 or is it just A?
No, A is A because they told us that from the beginning. Yeah, so A is not going to change. The only thing that will change will be what we're trying to find. So C2 is, when you cross multiply and solve that, you should get 1.398. So the only time that it's this much work is when there are two triangles. So let me zoom out a little bit. So we have two triangles. This is triangle 1. So this is triangle 1. And then these pieces of information that you see over here, this is for triangle 2.
And if there's two triangles, you always have to find the second one.
Yeah. Any questions? All right, we got one more and then we will end there and you'll have time to do your skills check. So let's look at example 7. I'll put it back up in a minute if you need me to at the end of class, but I don't have a whole lot of time. So, all right, let's look at example 7. So and it's also being recorded. So this is A, B, and C. Let's fill in what we know. I know that big A is 120, little a is 250, little b is 195. So we're going to start off by finding angle B again. Let's see if we have a B1. If we get an error, then we're done. We don't have to do anything. If we get something other than an error, we have to keep going. So let's set it up. We have our anchor pair. I have a side angle relationship. So I have the sine of 120 over 250 equals the sine of angle B over 195. And when you cross multiply it, you have 250 times the sine of B equals 195 times the sine of 120. And then we divide both sides and take the inverse. So that means that B1, I'm going to call it B1, is going to equal the inverse sine of 195 sine of 120 divided by 250. So go ahead, type that in your calculator and see what you get. So did you get 42.493? All right, let's find C1. C1 is going to equal 180 minus 120, which is angle A, minus 42.493. So C1, you should get 17.507. So all of this is triangle 1. So we got this is triangle 1, this is triangle 1. And the only thing we don't know is little c1. So little c1 is going to be, so now we're going to find little c, which is side c. So we're going to do our sine of 120 over 250 equals the sine of big C over little c. Go ahead, cross multiply and solve that for little c. Now because I'm trying to, so this is little, this is big. And then I'm going to change that for next year. I'm not going to use A, B, and C because lowercase c and uppercase c look the same and that's confusing. So I'm going to use D, E, F or something. And when you cross multiply it, you should get 250 times the sine of 17.507 divided by the sine of 120 should give you what did I get? Oh, 86.84. Is that what you all got when you typed it in? So the only way there could be a second triangle, so I'm going to put a question mark because we don't know. We already know that angle A is 120. B2 would have to be 180 minus B1. So that's 180 minus 42.493. Go ahead and type that in your calculator. Let me type it in because I didn't type that in last year when I made the key. So that gives me about 137. So with these two angles right here, is this even a possibility to have a triangle where you have two obtuse angles? You can't have a triangle with two obtuse angles. So this is a no-go. We don't have a second triangle. This is only one triangle because the second triangle is not a possibility. Triangle sum 180. Yep. Clear off your desk. Pencil only. Please don't use red ink because it's in skills check. When you're done, turn it into the red tray. Write your first and last name and your class period. Oh, okay. No bearing. Oh, I'm sorry. Excuse y'all. When you're done, turn it into the red tray.